Across the globe, a network of eyes and ears look to the sky. They tilt and sweep, catching signals from space explorers across the solar system or in orbit around Earth. These ground stations gather data collected in space and also act as mission control's voice, transmitting commands and controls, the means of communication between spacecraft and the engineers who sent them on their journey. This is ESA's Estrack network. The Estrack network is a global system of ground stations linking European spacecraft to the agency's Mission Control Center in Darmstadt, Germany. Whether they are circling Earth, watching the Sun, observing distant stars, or voyaging to other planets, asteroids or comets, these technically advanced ground stations and antennae can link up with any ESA spacecraft.
When you think about space, we never think about the very important ground network, because you couldn't communicate with the satellites if you wouldn't have the ground network, and this is absolutely essential.
The core network comprises 7 stations on 3 continents, with 3 large 35-metre deep space antennae in Australia, Spain and Argentina. 4 stations with smaller antennae are used for communication with nearby Earth-orbiting missions. They are located in Belgium, Portugal, French Guiana and Kiruna, Sweden.
Kiruna is an strategic asset for within the Estrack core network, playing a fundamental role for the support of all ESA missions with our own infrastructure.
Kiruna within our Estrack station network stands out, first of all for its privileged latitude, high in the north, so it can capture most of our polar orbiting satellites, typically Earth observation satellites, but it can also serve some of our science missions, like our Gamma Ray Observatory Integral.
In 1986, ESA and Sweden agreed to establish satellite tracking facilities near the top of the world, in the region of Salmijarvi. Eventually, the station was constructed on a 20-hectare site, some 38 kilometres east of Kiruna town.
Kiruna is the northernmost ground station of the Estrack family. It sits beyond the Arctic Circle at about 68 degrees of latitude, and this is an optimal geographical location for the support of polar orbiting satellites, providing increased communication opportunities for this kind of mission.
In the agreement, Sweden designated the Swedish Space Corporation to carry out on-site operations, and today SSC experts continue to run the station.
I started in 1988 as a technician. On my first working day, we started bringing in the ERS-1 processing equipment into an empty building.
On the 6th of September 1990, King Carl Gustaf XVI of Sweden inaugurated the Kiruna site. It consisted of a newly constructed building, a primary and emergency power plant, roads, data cables, a calibration site, and a single 15-metre dish antenna, Kiruna 1.
The relevance of the station is remarked by the inauguration 30 years ago, when the King of Sweden himself, together with the former Director General of ESA, Dr. Rainer Lust, pushed the button that triggered the first track of the antenna as a symbolic act of the beginning of the operational life of the station.
I got the task of trying to solve the problem that this button should activate the antenna movement. So at the time we had a laptop with a computer program which I could pre-program the movement of the antenna. But how should I connect this button to it? In the end, it was a very simple solution. I sat myself inside the antenna in front of the computer. When the king pressed the button, the sirens went off, and I just pressed the enter button of the computer.
In July 1991, the station began routine support to ESA's new ERS-1 mission. A few years later, in 1994, the station's systems got their first upgrade, meaning the station could support the follow-on ERS-2 mission. This enabled tandem operations with ERS-1, a first for European spaceflight.
In 2002, ENVISAT was launched, and Kiruna was providing support as prime station for telemetry tracking and command, as well as for X-band reception and processing.
When Kiruna took on communication responsibility for this then new ESA satellite, it was the largest civilian Earth observation satellite ever flown. And it was clear that this 8-ton satellite and its 10 onboard instruments would generate large quantities of data. A station upgrade was required, and a second 13-metre dish antenna was installed for high data rate capability, using high-frequency X-band radio signals. Over the course of 30 years, the Kiruna station has established an enviable record, providing reliable communication links with dozens of Europe's most important missions, such as ERS-1 and 2, ENVISAT and GOCHI.
Kiruna is basically the backbone ground station for the Earth observation missions. We all know it, we all use it, it works, and it's ours.
Today, Kiruna provides tracking services to the Copernicus constellation, composed of Sentinel-5P and the Sentinel-1, 2 and 3 satellite pairs. ESA's Earth Explorer missions, such as Aeolus, Swarm and Cryosat-2, are also part of Kiruna's daily tracking schedule.
Almost all Earth observation missions have polar orbits and pass some 10 to 15 times over the pole. And a station close to the pole can contact with satellites 10 to 15 times a day.
In a typical month, more than 750 hours of communication link-ups are made between Kiruna and passing satellites, up to 15 different spacecraft in all. This means the station is providing an average tracking support for over 25 hours each day with its 2 antennae. These communication passes enable the station to download vital science data and upload fresh commands for the coming orbits. For most Earth observation satellites, this is usually done in a very tight time window of just 12 minutes, while the satellite is in direct line-of-sight view.
Kiruna is also an example of a station which is multi-mission, which provides different kind of supports and can be reconfigured very quickly due to also the nature of the passes, which are normally not for polar orbiting missions, are never more than 10-15 minutes. It's a different story if we talk about Integral. As a science mission describing a highly elliptical orbit, the passes of Integral are often exceeding 50 hours coverage from Kiruna, so the antenna moves very, very slowly.
Kiruna's antennae and station systems are operated remotely from the Network Operations Center, located at ESA's ESOC Control Center in Darmstadt, Germany. Here, operators are on duty 24 hours a day, year-round. This efficient workflow allows the station's electronic and data systems to be quickly reconfigured between communication passes with different satellites.
Generally what we do is we prepare the commands in advance that we're going to uplink in a certain pass, so typically a Kiruna pass. These commands will execute offline out of coverage mostly, and after the following passes we will check that those commands are successfully on board and that the satellite is behaving as it should be.
For maintenance and day-to-day troubleshooting on site, Kiruna relies on a local team of engineers. These specialists also work on console if direct intervention is needed during critical spacecraft maneuvers or launch activities.
Kiruna has a backup control center. This is a mini system which allows ESOC to command the Sentinels, Sentinels 1, 2, 3 and 5P in case of an emergency here in ESOC.
Another important feature of the Kiruna station is its ability to provide vital real-time contact with new satellites during their launch and early orbit phase, or LEOP. In this period, it's crucial to quickly and accurately catch a spacecraft's first signals only minutes after launch, allowing operators on the ground to take control of the mission and switch vital control systems on. This critical capability means that when mission controllers need reliable communication in risky situations, they often rely on Kiruna. In the past decade, the station and its maintenance and operations team have typically supported one launch every year.
Kiruna also guarantees us the technical excellence of ESA behind the ground station. So for this very specific phase, where we could encounter all sorts of contingencies, where we don't know where the contingency actually is, whether it's a spacecraft issue, an orbital issue, an radio frequency issue, we know we have the experts here on site who know the station inside out and are ready to collaborate with us and to find a way out.
As space technology develops and space becomes increasingly important to daily life, the Kiruna station will continue reinventing itself. It will have to support new missions and accommodate future technologies. New missions are already downloading several terabytes per day, or even per pass, via Kiruna, and in future this will only increase as the amount of data gathered by satellites and the knowledge this provides grows exponentially.
During the 30 years of operational life of Kiruna, the station has continuously undergone a gradual development and expansion, mainly driven by the challenging operational requirements from the multiple missions supported. And this trend will continue in the future. Emerging technological trends are coming together with the new series of Earth observation and scientific missions.
The main driver of station evolutions is, of course, the needs of the various missions and the direction where these missions are converging. Mainly now we talk about S-band and X-band as Kiruna supports, but it's already reality higher frequency bands like K-band at 26 GHz, where the bandwidth, the available bandwidth is much larger and the amount of data that can be dumped to the station from the satellite is considerably larger.
In the next decade, the evolution of the Copernicus program will add more satellites to be supported from Kiruna. That will require more tracking hours and new capabilities.
ESA aims at further evolving the station to keep on playing a fundamental role in the support of this mission during critical and routine phases, as well as to serve as a reference facility for the validation and troubleshooting of new technological developments. So 30 years has served to consolidate Kiruna as an Estrack reference station for the support of near-Earth communications, and solid foundations are laid to continue its expansion and development to the support of the mission to come.
For Kiruna, this will be a challenge, but also an opportunity to once more demonstrate its importance as a vital link between Earth and space. We can no longer conceive of a society without space technology. While we might often think of the importance of satellites orbiting our planet, or spacecraft voyaging to distant destinations, we should not forget how crucial ground stations like Kiruna are, how they make space possible, and how they help humanity move into the future.